Welcome back to our channel. In previous videos, we learned the sum, difference, and product rules. But what if a function is a fraction, meaning one function divided by another? Today, we'll learn the quotient rule, which handles exactly this scenario. Firstly, what does this quotient rule say? If you have a function divided by another, say f of x divided by g of x, the derivative is derivative of the numerator times denominator minus numerator times derivative of denominator, all divided by the square of the denominator. Remember the order: f prime times g minus f times g prime over g squared. In order to ease the application of set method, we were able to establish 6 simple steps. Firstly, identify f of x, which is your numerator, and g of x, your denominator. Secondly, differentiate f of x, that is f prime of x. Thirdly, differentiate g of x, that is g prime of x. Fourthly, compute f prime times g minus f times g prime. Don't miss the order. It's f prime times g minus f times g prime. Fifthly, divide by g squared. And lastly, simplify if possible. So in order to apply this method, we are going to take an example. Example 1, which is an example on simple polynomial fractions. It states, differentiate y, which is equal to x squared plus 1 on x. We are going to apply the 6 procedures or the 6 methods, the 6 steps which we were able to establish just above. So what was our first step? Identify f of x and g of x, that is your numerator and denominator respectively. So first, we'll say let f of x, which is our numerator, be equal to x squared plus 1. Identifying our denominator, we will let g of x equal to x. So we are done with our first step. Moving on to the second step, it tells us to differentiate f of x. F prime of x is equal to the derivative with respect to x of f of x, that is our numerator, and this is equal to the derivative with respect to x of what is our numerator, x squared plus 1. And this gives us derivative with respect to x from our sum rule of x squared plus derivative with respect to x of 1. This then gives us 2x to the 2 minus 1 using our power rule plus 0 using our constant rule, which states that the derivative of any constant gives us 0. Simplifying this, we have 2x. Moving on to our third step, which tells us we are already done with our first and second step. Our third step tells us to differentiate g of x, that is g prime of x. Now, g prime of x is equal to the derivative with respect to x of g of x, which is equal to the derivative with respect to x of x. And this gives us 1x to the power 1 minus 1 using our power rule, which is same as 1x to the 0, which gives us the constant 1. So we can then conclude that our derivative of the denominator is 1 and the derivative of our numerator is 2x. We can then move on to our fourth step, which tells us to compute f prime of times g minus f times g prime. F prime times g minus f times g prime is same as f prime of x times g of x minus f of x times g prime of x. First of all, what is our f prime of x? It is 2x times our g of x, which is x, minus what is our f of x? X squared plus 1. You notice I put all of that in bracket. And our g prime of x, which is 1. Simplifying this, it gives us 2x squared minus x squared minus 1. What is 2x squared minus x squared is same as x squared. It simplifies to x squared minus 1. So we are done with our fourth step. Moving on to our fifth step, it tells us to divide this computation by g squared. First of all, we need to calculate g squared. So what is g squared? G squared is same as g of x, all that to the squared. And what is our g of x? X squared, which is x squared, obviously. So we then compute it. F prime g minus f g prime, all that divided by g squared, is same as, this is our f prime g minus f g prime, x squared minus 1. And what is our g squared? X squared. This can still be simplified to x squared on x squared minus 1 on x squared, which gives us 1 minus 1 on x squared, which is same as 1 minus x to the minus 2. So we can then conclude that the derivative of our function y, which is same as f prime g minus f g prime, therefore derivative with respect to x of y, which is same as derivative with respect to x of what was y? X squared plus 1 on x squared plus 1 on x gives us 1 minus x negative 2, or we could still leave it as x squared minus 1 on x squared. We are done and complete with our derivative. So we are going to move on to a second practical question, or a second practice question, in order to ensure we have well understood this method and this concept. Practice question 1. Practice question 1. And this practice question 1 is a question on polynomials divided by polynomial. So what does this question tell us to do? Differentiate y equal to 3x squared minus 5 divided by 2x plus 1. So I'm going to leave you guys some time to attempt this question and put your answers in the comment box below, and each and every one of us are going to get down to it with our own reviews and remarks. So starting this question, I'm going to assume each and every one of you have attempted and have a sort of a solution or a sort of an answer. So first of all, we are going to follow the same methods, the same procedure, the same steps which we enlisted above. What was our first step, if you can still remember? Step 1 was to identify our numerator and denominator. So first of all, we are going to let f of x be equal to our numerator, which is 3x squared minus 5. Moving on, we will still let g of x equal to our denominator, which is 2x plus 1. Most of you might ask, why are we letting f of x and g of x? We are letting them because in the initial question, f of x and g of x were not defined functions. So if you want to say the numerator should be equal to f of x, we need to let it. Yes, because we are then defining f of x. Yes, so f of x was not defined by the question, but it is a function, or it is a variable which we, the people solving the question, are defining. So after letting our f of x be the numerator and letting g of x be the denominator, we move on to our second step. What did our second step ask us to do? Our second step asks us to calculate the differential or the derivative of a numerator, that is f prime of x. So f prime of x, which is the derivative with respect to x of 3x squared minus 5. Using our difference rule or our sum rule, This is same as the derivative with respect to x of 3x squared minus the derivative with respect to x of 5. From our constant multiple rule, it is same as 3 times the derivative with respect to x of x squared minus the derivative with respect to x of 5. This is 3 times, using our power rule on this, we have 2x to the 2 minus 1 minus derivative of a constant from our constant rule gives us 0. Why? Because the derivative of any constant is 0. So this can then simplify to 6x. Moving on to our third step, which tells us to find the derivative of our denominator, that is g prime of x. This is equal to the derivative with respect to x of 2x plus 1, which gives us derivative with respect to x of 2x from our sum and difference from our sum rule plus the derivative with respect to x of 1. This then gives us 2 times the derivative with respect to x of x from our constant multiple rule plus the derivative with respect to x of 1, which then gives us 2 times 1x to the power 1 minus 1 plus derivative of a constant gives us 0, giving us 2. Moving on to our fourth step tells us to compute f prime g minus f g prime. And this is, what is, first of all, what is f prime? F prime is 6x times, what is g? 2x plus 1 minus, what is f? F is 3x squared minus 5. 3x squared minus 5. And what is our g prime? Times 2. Simplifying this, we have 6x times 2x plus 6x minus, in bracket, 2 times 3x squared minus 5 times 2, giving us 6 times 2, we have 12x squared plus 6x minus 6x squared minus 10, giving us 12x squared plus 6x minus 6x squared plus 10. Simplifying this further, we have 12x squared minus 6x squared giving us 6x squared, that is 12 minus 6 here, plus 6x plus 10. Moving on to our fifth step, it tells us to divide this computation by g squared. But before doing that, we first need to calculate g squared. So what is g squared? G squared is, what is first of all our g? 2x plus 1. So it gives us 2x plus 1, all that squared, which is same as 2x plus 1 into 2x plus 1, which gives us 2x times 2x plus 2x plus 2x plus 1, giving us 4x squared plus 4x plus 1. Okay, we can then divide the top computation by g squared. So f prime of g times g minus f g prime divided by g squared then give us 6x squared plus 6x plus 10, all divided by 4x squared plus 4x plus 1. We can then conclude our conclusion. Therefore, the derivative with respect to x of our initial function y, which is same as the derivative with respect to x of what was our initial function f on g, which is 3x squared minus 5 divided by 2x plus 1, 3x squared minus 5 divided by 2x plus 1 is equal to 6x squared plus 6x plus 10 divided by 4x squared plus 4x plus 1. We are done with our solution. Moving on to a second practice question or a third example, in order to firmly affirm that the concept has been understood. Practice question 2. This is a question on fraction with negative powers divided by constants. So what does this example ask us? It tells us to differentiate x squared on 3x cubed. So using the same steps, we first identify our numerator and denominator. So let f of x be equal to x squared. Let g of x be equal to 3x cubed. Moving to our second step, which tells us to differentiate the numerator. F prime of x is then equal to the derivative with respect to x of x squared, which gives us 2x 2 minus 1, giving us 2x from our power rule. G prime of x, which is derivative with respect to x of 3x squared, 3x cubed, gives us 3 times derivative with respect to x of x cubed, which is same as 3 times 3x to the 3 minus 1, giving us 9x squared. Computing f prime g minus f g prime gives us f prime 2x times g 3x squared cube minus f x squared times g prime 9x squared. This simplifies to 6x to the 4 minus 9x to the 4, which simplifies to minus 3x to the 4. Computing then g squared, which gives us 3x cubed, all that squared, is same as 3 squared times x 3 times 2, which gives us 9x to the 6. F prime g minus f g prime divided by g squared then give us negative 3x to the 4 divided by 9x to the 6, which gives us negative 1 divided by 3x to the 2, which can then simplify to negative 1/3 x to the minus 2. We can then conclude that the derivative of y with respect to x is equal to negative 1/3 x to the negative 2. This is a simple case where the quotient rule gives a clean result. You could also simplify this first, but quotient rule works systematically for any case. If we simplify this, we would have gotten y, which was equal to, what was y? X squared on 3x cubed. X squared on 3x cubed. We would have gotten 1/3 x to the negative 1. And differentiating this, y prime, would have gotten 1/3 negative 1 x to the negative 1 minus 1, which gives us negative 1/3 x to the negative 2, which gives us the same answer. So this is just to affirm that the quotient rule works systematically for any case. So what are the common mistakes we're able to highlight that most students usually do? Firstly, most students forget f prime of g or f of g prime. That is, instead of doing the total computation f prime g minus f g prime, most students might forget one of the terms. Another mistake is they swap the terms. That is, instead of computing f prime minus f prime g minus fg prime, which is correct, they compute fg prime minus f prime g, which is wrong, which is very, very wrong. Another term is they forget to square the denominator. That is, instead of computing f prime g minus fg prime divided by g squared, they do f prime g minus fg prime divided by g, which is wrong. The fourth mistake is they ignore domain restrictions. So all of this is just to say, always remember the numerator derivative first minus numerator times denominator derivative. Then divide by square of the denominator. Then divide by the square of the denominator. Yes. So just a brief recap on what the quotient rule says. The quotient rule says if you have a function divided by another, say f of x over g of x, the derivative is derivative of the numerator times denominator minus derivative minus numerator times derivative of the denominator, all divided by the square of the denominator. So in the next video, we'll tackle the chain rule, which is the key for composite functions. Thank you and see you in the next video.